this then. So they say we have a rectangular area. They want is obtained by enclosing 3 sides, unlike the one that we had. Now we're enclosing 4 sides. So this time around, we are using, because we already have this existing edge. So because we have this edge, we're not going to put another fence here. So our fence is needed for 1, 2, 3 things.
Oh, yes.
Does that make sense, Renee?
Yes.
So yeah, so they say existing edge, which forms the 4th side. So this part here, we're not going to be using it with our fence. Remember, here's our fence. Using this fence, when in your fence now, you already have one side that you're not going to be using because it's the wall exists. So whatever it is that you're going to be doing you're going to be doing it for 3 sides. Okay, let's go to the question. What does the question want then, Renee?
Find the maximum area of
find the maximum area. Yeah, find the maximum
of the
area of a
rectangular
rectangular
area.
If the dimensions
Area each dimension, if 100 meters of fencing is available.
So it means, which unlike the one that we had, now we had 25 meters. Yes. Well, now they have how much, Mike? 100. Oh. So, Mara, what is it? This is keyword. Keyword. What is it that they are maximizing? What is it that they are maximizing? Area. They are maximizing the area. We are going to write the formula for area of a rectangle. Area of a rectangle. So we say we have area, which is going to be x multiplied by what? By y. Because already they have x and what and y. That's how we get the area. Yes.
Last time I filled 25 and what was like perimeter. How do you know what's perimeter, Mister?
Like they will tell you, like here, they said the dimensions 100 meters.
I've already find the maximum area of the rectangular area and
its
dimensions. If 100 meters
of fence is available. So the only fence that we have, it's 25 meters long. So that's the perimeter of.
Okay.
Yes. So here, what did you say about perimeter, Madison? How many X's do you have here? Check for the fence.
Y.
You have Y, ne? How many Y's do you have?
2 X's.
You have 1 Y and 2 X's. So you're going to say Y plus 2X is going to be equal to what? 200. Why are you doing this now? We're trying to eliminate the X multiplied by Y.
Yes.
So you're going to make Y the subject. Make Y the subject. You're going to have Y, which is going to be equaling to 100.
Or Mr.
Minus 2x.
100 minus
we're not using it for fence. Actually, we have 100 meters of the fence. Yes, yes. The fence is 100 meters. But when I was doing it, I said x multiplied by y.
Yes.
So look at this then. What am I going to tell them? I'm going to tell them which area is going to be given by x multiplied by. Instead of y, I know what is y again now.
Yes.
100 minus 2x.
100 minus 2x, sure. So we're going to put 100 minus 2x. So what should we do from here? It's simple here.
Multiply.
It's this one multiplied by this one again. It gives us what?
100x.
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 And then this one multiplied by this one gives us minus 2x squared.
Minus 2x squared.
Now remember, we go back to this word, maximum. When we maximize an area, it means you are going to differentiate the area. That's the goal here. So you want to differentiate the area, and then after differentiating the area, you want to make sure you make the derivative to be 0. So I'm going to continue in that direction. So I'm going to have area prime. First, make sure with all the variables that you're differentiating in terms of on the numerator.
Yes.
So you're going to have what? You're going to have 100. Madison, 100 what?
100 minus 4x.
Minus 4x. Ne? And then you put 0 here.
Yes.
Yes. As soon as you put 0, you're going to have 100 minus 4x. Take the 4 to this other side. It says 4x is going to be equal to what? To 100. And then it says which x is going to be what? 25.
25.
So you can tell them, okay, I know what is this. This is 25. But now they said they wanted what? Find the maximum area. We're not done. If they want the maximum area, we can get y, or we can take this 25 and substitute it here. It's up to us. I substitute on the original equation, man. On the original equation, not on the prime. We're going to substitute it on the original equation. Sometimes they can say, give us the lengths like give us the length of this thing. So you need to tell them what is x, you also need to tell them what is y.
But I'm still, if I find the maximum area of the rectangular area and its dimensions, I will include the x and y or body on. Because
Oh yeah, they also want the
it's-
dimensions.
yes.
Yeah, that's what I was saying. Yeah. So let's get y. So we got x and this. Now how are we going to get y? We're going to get y by the formula y, y. You are saying y is equal to 100 minus 2. Yeah, so we're going to have 100 minus 2 multiplied by 25,
Which is 50.
which is 50.
Yes.
And it makes sense, it's bigger, this one.
Mm.
We just didn't expect it to be 2 times. And then from here, finding the area then is simple. Once you have x and y, you don't have to use this thing anymore. You can simply say, I know area. From experience, it says it's 25 multiplied by 50. What is 25 multiplied by 50?
1,250.
1,250.
So mistake.
And then this is going to be meters squared.
Fifty.
And then for something like this, you're going to get your 5 marks.
So mistake.
Mm.
Lengas kere y and then can over straight.
Yeah, but here they required us to calculate y because they said the dimensions.
Oh.
They said calculate the maximum area of the rectangular and its dimensions. So we needed the dimensions. Thank you, Madison. Let's give Madison a round of applause. Guys from the group.